Okay, so we're just looking at skewness of data, and what I've got here, so it's 9 slides, so we'll try to get through it as quick as we can. So sometimes when collecting data, there's times when the data's not evenly spread, and we've got clumps or bunches of data at one end or the other, or there may be a number of clumps, okay? So copy that down, and when you're ready, come across. Okay, I'm going to stretch myself. Okay, so for instance, here's an example of pretty symmetrical data when we measure people's heights or the marks in a maths test or people's time for running 100 metres. You get a general shape where most people are in the middle. Okay, so this peak here, changing pens, so this peak here, that would be the average, and then you've got some people at each end, but it's pretty symmetrical, they're spread evenly. Sometimes it doesn't have to be this nice little bell shape, we call it. Sometimes, again, we've got a peak in the middle and scores are spread on either side. And that's what, and you can recognise that pretty easily. Okay, so copy that and come across when you're ready. Okay, so we're back again. So now we're looking at positive skews. So, okay, here's some low numbers at this end, and these are the high numbers. And when the data is pushed towards the low end, we call it positively skewed. And when I was thinking of some examples, I thought maybe, you know, the number of pets you might own. Like for instance, most people might have 0 or 1 or 2, and some people on a farm might have 12 pets. So there is some data at the high end, but most people are skewed towards the left-hand end, the low end, and we call that positively skewed. Okay, so copy that and come across when you're ready. Okay, so now we're looking at, okay, we've still got low scores at this end, and we've got high scores at this end. And now this, most of the time the results are skewed to one end at the top. And an example that Mr. Goring gave was perhaps like if you're looking at the gestation of a baby, most babies are coming at 38 and 39 weeks, but you might get a few premature babies, and you might get a few babies that are overdue, but most are going to come at 38 or 39. Okay, so there's some results at the low end, but most are skewed towards the top end. Okay, so copy that and come across when you're ready. Okay, so now we're looking at bimodal. So bi, the prefix bi means 2, and mode is the score that occurs the most. Score that occurs the most. And so what we've got is, we've got a clump of data here and a clump of data here. There's 2 clumps. Okay, so for instance, an example might be when we're measuring people's heights, you might have the girls' average and the boys' average are going to be different numbers, and there's going to be an overlap, but that might be a representation of 2 modes. Okay, I also forgot to shout out to all my friends in Mr. Coe's class, especially people that start with the letter A. Okay, so welcome. And so just copy that and come across when you're ready. Okay, so now we've been looking at one type of diagram, but skewness, you might see skewness in histograms or stem and leaf or dot plots. And in the next couple of slides, we'll have a look at what that looks like. So can you copy that and come across when you're ready? Okay, so here's an example of dot plots, and you can see that if we drew it as a shape, the shape looks like that, so that it's pushed towards the top end. Okay, so that's going to be negatively skewed. Okay, and here's an example of a stem and leaf, and again, if you look at the shape, it looks like that. So the scores are skewed towards the lower end, so we call that positively skewed. And here, this is the histogram, the bar graph. The bars are all lined up against each other, but again, the shape is pretty symmetrical. Okay, so there's an example of how you can get skewness in different diagrams. So copy that and come across when you're ready. Okay, just a couple of little things. Outliers get mentioned in the exercise that you're going to be doing. So outliers are results that are not typical. They don't look like the rest of the results. And most of the time, you can eliminate them for purposes of describing the data. Okay, so you can use them and describe it, or you don't use them and describe it. But in the next page, we'll have a look at what an outlier looks like. But certainly, when you're calculating mean, medians and ranges, you don't use outliers, the results that aren't typical. But in terms of describing the skewness, normally you take them out. So let's have a look at the next slide when you're ready. Okay, so for instance, this score down here, this 5, there's a bit of a gap in between the rest of the data. So you can say that without the outlier, the data is symmetrical. So if you can actually say without the outlier, the data is symmetrical. But if you want, some people could say, well, with the outlier, the data is pushed towards the top end, so you could say it's negatively skewed. But most of the time, you don't use the outlier when describing the data. So in exercise 14E, I think it's, again, I'm just guessing a page number, about maybe 526 in the Year 9 textbook. There's questions 5, 6, 10, and 11 talk about that. So don't worry about any of the earlier questions in that exercise. Just look at those questions and that'll be fine. Okay, in an exam situation in Year 9 this year, you won't be actually asked to think of examples of skewness, but just looking at describing. Okay, that's it. Bye.